Now writing the EXTI 0 handler is pretty straightforward. So we have seen that how we can blink the blue LED in the case of the SysTick handler. So in the EXTI 0 handler, we are just changing the position of the LED. So the SysTick handler keeps blinking the LED, and here we are changing the position of the LED. That is, in the EXTI, if you press the user button now, so the purpose of the interrupt is this. So you have the blue LED here, and then you have the red LED and the green LED and so on. So what happens is, basically, so you have different colored LEDs. So say the blue LED is blinking now, the SysTick is blinking the blue LED. The job of this handler is, whenever we press the user button, we will see that the position of the blinking LED is going to shift to the next one, and then it is going to shift to the next one on the next button press, and so on. Job is to switch the LED position. How it is done is, we just go into the mode, GPIO pin mode, okay, and we set the output mode. That is in the mode register for the GPIO D, because the LEDs are connected to GPIO D, as we saw previously in another section. And we saw how we actually enabled the LED modes, right? So we had enabled the LED modes in some bit fields, right? So say we enabled the mode here. This interrupt does it closes this particular LED, it locks this particular bits, and it just shifts the enable bits to the next set of bits. That's all it does, and it keeps doing it in rotation. So when it moves to the last bit, it again switches back to the first bit. So, and that is why you have the percentage operator. Okay, so it keeps shifting to two positions to the left every time, because as we know, we have to set, so if every mode field is 2 bits, as we know. So suppose let's draw it. So suppose we have the register like this, and we have 8 bits in the register. So 8 bits. So every bit so 1 bit, the mode for 1 bit is represented, mode for 1 LED is represented using 2 bits, and this is how it goes, as we saw this one. Okay, so now what we do is we clear the bits. So it's clearing the bits means that we are no more using that particular port. So say it was output, so setting it as an output is going to be 0 and 1. Let's go and check the register also, in case you have a doubt. So let's go to MODER. So again, for GPIO, we have to come back to the reference manual. Let's see the mode register. So this is the GPIO port mode register, right? And we have 12, 13, 14, 15 for port D set as the connected to the LEDs. So 0, 0 is the input mode, which is the reset state. We have to make it output. So what we do is we will set it to 0, 0 as the default state, and if we have to output something, we will set it to 0, 1. And even if it's in the input state, if we try to output something through these ports, nothing is going to come out. So we will not see the LED blink. So that is the logic we are using here. So there is a 0, 1 here to make it an output port. So for for us, say this is the default state where we have the output set for the say blue LED. We are just zeroing out the whole thing and then moving 0 1 here, then 0 1 here, 0 1 here. So it just keeps moving like this, and the toggle LED basically outputs all ones. Okay, so it outputs all ones in the GPIO output register, and only that register where whichever is register field, that is say the 2 bits whichever is set as output, is going to let that particular LED glow, and the rest are going to be off. So that is the logic that we are following. So we shift 0 1 to left by 2 places every time, and then once it comes here, we again move back to this location. So this is the logic that we are following here. So and then again clear pending for the EXTI. This is not the clear pending for the NVIC, and this has to be done, otherwise the interrupt stays in the assorted state. So this bit has to be cleared every time we are. So interrupt specific stuff is this, that is the pending bit has to be cleared. Rest of the interrupt handler is whatever you write. But and then again we have in the settings we saw last time, we could set the priority to higher and lower. So let's see what is the priority set to now. It is 0x4 right now for SysTick, and it is, let's see what is the priority we have set here. It is 0x1. So this one is a higher priority. So this EXTI 0 port A0 is a higher priority. So let's compile the code and we will see a run on the board. We'll press the user button once and we'll see what happens to the LED. So let's compile the code and let's hope that it runs. Let's do a clean and let's do a compile. So we get some errors. We have got some errors. So let's see what the errors are. Undefined reference to configure int i0 port a0. Okay, so we have forgotten to change one call, which is, so we have configure xt0 port a0, but in the main we have not done it. So we do xt0 port a0. So now this should work. Okay, let's try to recompile and check. So we see one warning. Let's see what warning we have got. Yes. So again, the configure xt0 port a0, whatever we change now, needs to be declared here. So again, let us make it configure xt0 port a0 here in the header file for the core initialization. So you will face such situations, such problems where you will probably be needing to, once there is a mistake or once you need to change the name of a function you change the name of a function, it has to be changed in multiple places. So you have to be wary of that. You have to be careful about that. Yeah. Now we have 0 errors and 0 warnings. So the program seems to be working fine. So now we will see a demo of that, and we will see what this LEDs actually do when we press the button. So So now we will see another demo, small demo, where if you remember, we had enabled the LED or enabled the this EXTI0 interrupt in software when we were discussing about the preemption scenarios. So what we'll do is we are going to enable the interrupt, set the interrupt number 6 as pending, but this time since we have the opportunity once again, we'll do it through the STIR register, because the STIR demo was not done that time. We showed it through the NVIC ISPR register. So now we are going to enable, set the state of the EXTI interrupt through the STIR register. So let's do EXTI0 and then set the pending state. And now we will not be pressing the switch. Every time it comes into the SysTick handler, it is going to invoke the EXTI0 interrupt. And when it invokes the EXTI0 interrupt, as the EXTI0 interrupt is higher priority, the interrupt is going to switch the LED position. So that is what is expected of the program. So let's see if it compiles and runs as expected. And we will see something strange happening on the board.